Hey guys, this is Stiller here, and today we are solving the third problem of weekly contest 464, which is jump game IX. So this is very interesting problem. So let's get started. So question description is pretty clear. Let's quickly go through it. You are given an integer and nums. Okay. For any index I, you can jump to another index j. I can basically jump to another index. What is the criteria? Criteria is jump to index j where j is greater than I is allowed. Only if nums of j is less than I, and jump to index j where j is less than I is allowed only if nums of j is greater than I. I will tell you this thing very clearly. And for each index I, find the maximum value in nums that can be reached by following any sequence of valid jumps starting at I. Return an array answer where answer of I is the maximum value reachable starting from index I. Let's quickly see what is given to us. So let me take an example. Here is my example. So what we can do, let's say I am at index 4. Okay, I am at index 4. Now from this 4 I can jump to any index from left side if that number is greater. Okay, if that number from left side I can jump if number is greater. Okay, greater. And I can jump to the right side if number is smaller. You just need to remember this thing, and question will be very clear. So at any index, if you found any element which is greater on the left side, you can definitely go to it. This is greater, this is greater, this is greater. You can go to any of the index. If any index you can find smaller than this one, so you can go. So in this case, you can't go. But let's say if you are on 5, you can go to this. No, sorry. You can go to this 2. You can go to this 1. You can go to this 4. Yes. So just key thing is any index which is on right, if it is on right, it should be smaller, you can go. On the left, it should be greater, you can go. So question conditions is clear, okay, where we can jump. Now let's see, okay, what is the answer of this question. So at any index, if let's say you are at 4, okay, so you may jump to 5, I think. Okay, you may jump to you may jump to I think 1 here, you may jump to 2 here. Okay, now what is the answer? So I want to maximize this answer. Okay, so I will try to go to this 7. So how I will be jumping, I think I will take this jump 2, and then from this 2 can I go to 7? Yes, because this is from left side and this is greater, so I will that way. From 4 I will go to 2, and from 2 I will go to 7. If there is any path from 4 to 7, direct or indirect, so I can say that I can return an answer of 7 here. Okay, I can return an answer of 7 here. Let's try for 5. Can I reach 7 or any greater element than this? Let me try. So from 5 I can go to 2, and 2 I think I can go to 7. Okay, so similar. So if right side it's a smaller, I can go. Then from 2 left side and it's greater, yes, I can go. So from 5 I can go to 7. Okay, let's try for 2. For this 2 where I can go, I think I can go to 1, right? And from this 1 I think I can go to 5, and from 5 my answer is already 7, so I can write a 7 here. So this is just a kind of graph problem where you need to explore paths. You need to reach the maximum node. Okay, and what is the condition? The only condition is for each node you can go to the left if that number is greater, and you can go to the right if that number is small. Super. Now, how to solve this problem? So, the intuition, or like the idea behind solving this problem is you need to think in a brute force manner. Okay, so you will go to each node. Okay, you will go to each node, and you will see. Let's say you came here. You came here. Okay, and if I say you like think in a total brute force manner. What is the possible answers of this? I think one possible answer is whatever the maximum till now. Whatever the maximum till now, can I say that can be one of the answer? Why? Because I can definitely go here, right? I need to maximize my current answer, and I need to basically get the maximum possible answer. So I think the current maximum till now, that can be my one of the answer. Okay, so my one of the answer is like possible answers if we write. So one answer is max till now, or I will say prefix max. Okay, prefix max or max till now. Okay, so if I am at whatever maximum till now can be one of my answer because this is minimum and I can definitely go to that number. The second possible answer. So let's say if I am at 4, okay, I am at 4. Now I think I have 5 can be one of my answer. Okay, 5 can be one of my answer. What is the next possible answer? Next possible answer is maybe I think I can go to this 2, right? I think I can go to this 2. And from this 2, I think I can go to this 7, right? So how I figure out this answer? What I did, I tried to find the minimum number in the right side. I tried to find minimum number less than like which is less than 4. So for this 4, I think this 2 is minimum and this 1 is minimum. Okay, so what I'm doing in the brute force I'm talking about, for this 4, what is the minimum? I think this 2 is minimum. Are there any elements in this range which is greater than this 4? Yes it is, yes it is. 7 is the answer. Okay, so that's why I have kept 7 here. For this 4, I think another minimum is this one. Are there any elements in this range which is greater than 4? No, there are no elements. So this answer is not giving me any answer. So that way, I hope like brute force approach is clear. Let's try and for this 5 as well. So for this 5, what I can go? I think I can go to this 2. Like I will try to find minimum number from the right side because left part I have considered. How I have considered? I am taking the highest. I am taking the like highest number, prefix maximum number till now as my like left part is considered. Left part is sorted. I'm trying to find the right part, like how far, like how what better answer I can get from the right side. So what I'm doing here from the right side, I'm trying to find the minimum number because I can only go to the minimum number. So let me try to go here because I can go here. Now from this two, where I can go? I think I can go to 7. Why? Because this is following the property. I think this is the next answer. This is the next answer. Like from this one, are there any numbers which are greater than this 5 in this range? No, and no, it is not. But in this range, yes, it is. 2 is the minimum, then 5, and there are numbers which are greater than 5. So 7, from 2 I can reach to 7. Yes. So that's how that is basically the brute force solution of this question. Now let's talk about the exact solution. Okay, for that let me write the prefix and suffix minimum, prefix max and suffix minimum. If you don't know what it is, prefix max is basically I will try to calculate prefix maximum like this. So prefix max will be I think 2, then 5, then 5, then 5, then 7, then 7, then 7. What I am doing? I am doing just I will start from here, okay? 2 comma 2. Now I will check whether this 5 and this 2, what is greater? I will put the greater. Like from and the next step, I will take the last prefix and the current element. What is greater? I will put here. Okay. Similarly, last prefix, what is greater? Current element, what is greater? 5 is greater. Then last prefix, current element, what is greater? 7 is greater. So I will put it here. Okay. Similarly, I will try to find suffix from the left side, from the right side. Okay. Let me try to calculate it. So I think 6, then 2, then 2, then 1, then 1, then 1, then 1. So this is my suffix array. Okay. This is my prefix, this is my suffix. Now, just to make question little simpler for you, I will write the code first. Okay, we will write the code first because code is very easy. But the idea how that code is working, that is little tricky in this question. So let me first write the code or maybe pseudo code you can say. Then we will try to understand how why that code is basically working. Okay. So first, like I will not write in very detail. I will just quickly write it. So first of all, we will try to calculate prefix max. Okay. So prefix array would be something initialized with 0 with length n, and what will we do? We'll be calculating it. Okay, I don't think I need to write this whole code here. So next we'll be writing suffix minimum. Will be like in the same manner. I think you guys can write it. From left side, we'll try to calculate prefix max. From right side, we'll try to calculate suffix minimum. Okay, super. So once I have calculated these two things, suffix minimum will be initialized from 0 and we'll be calculating it here, okay? And we'll be calculating it here. Now what is the next step? This is step 1. Step 1. Now step 2. Let me write step 2. Now I will be starting from for I equal to n minus 2, okay? For I like I will be initializing answer equal to something like this 0 into n. Basically, I'm initializing all values with 0. I am saying answer of last index equal to nums of, okay, prefix of last. Why? Because like answer to this last element will only be only one thing. There is nothing in right. There is nothing on right for this last number. There is only on the left numbers. So what is the maximum I think this if this is highest number, then I can't change it. And if this is a smaller, I can jump to the highest. Definitely I can jump, because whatever rule says from left side you can go to the greater, so definitely I can go to this greater. So that's why my last answer would be the prefix. Okay, at any point our possible answer is max till now. Okay, max till now we have already discussed. So in that manner, I think last answer would be only prefix of it, last. Okay, now, the next thing I will be doing is I will be starting from the last second index. Okay, from last second index I will be starting, and I will be going till 0. Now, what will be my answer? I think my first possible answer is answer of I would be, I think, prefix of I. Okay, what is the highest maximum answer till now? What will be my second answer? So I will tell you, if prefix of I is greater than suffix of I plus 1, then this happened, suffix of I plus 1, then my answer would be answer plus 1, I plus 1. Okay, answer of I would be I plus 1. Now, what I did just here. So, this is the only part of solution for this question, and we will be done. Let me tell you in detail what we done here exactly. Okay, so let's try to understand this part very deeply. Okay, here I have written one example, and one rule of thumb you need to know. So if you are at current position I, you can move to left if you can move to left if that number is greater. You can move to right if that number is smaller. Okay, that this thing you should remember. Okay, the next thing you should remember is there is always path from 2 to 7. Why there is always path from 2 to 7? Because 2 is smaller. Okay, this is my current I, left number is greater, so I can directly move to this. So this will be using many times. Super. So now let's try to understand. It's very easy, just be careful. Okay, so let's say I'm at 4. Okay, I'm at 4. I will try to apply this formula. Okay, so what is the prefix max till here? I think 5 is the prefix max, right? What is the suffix I plus 1? Suffix I plus 1. Okay, I think 1 is a suffix I plus 1. 1 is the only smallest element among all of this. 1 is the suffix I. Let me write it down. So prefix max equal to 5. Suffix minimum is equal to 1. Super. Now, uh, there are two cases. Okay, currently we can see that this is 5, this is 4, but at a runtime program doesn't know that it is 5, it is 4. Okay, so we have two cases. Either the max number will be present here only. Okay, I'm talking about only this index. Okay, super. So my two conditions is either my prefix max will be here, or my prefix max either like on this part, on this left part. Okay, oh, I hope you got it. Super. So either my max will be here, or my max will be in either here, or any part. Okay, let's talk one by one. Let's say my max is here. Okay, this is, let's say, 7, or let's say 6. It is 6. Okay, for example, it is 6. Now I need to find out. Okay, for now, for example, this number is maximum. Okay, so prefix max will come as 6. Super. Now I need to check. Left part is sorted. Okay, left part I am having 6 as a maximum answer. Okay, this is left part. But right part I will be checking whether this 6 is greater than I plus 1. This number, like, what is the suffix I plus 1? I think 1. Okay, so 6 is greater than 1. Yes, it is. Yes, it is. What I need to do, I need to update answer I equal to I plus 1. Now let's see why it is, why this answer is valid. So we will move step by step. Okay, this is 6. Okay, for example, what will be my approach? I think I can move to right and smaller number. Okay, I will move to right and smaller number, and from this two I can definitely go to 7. So with that I can reach a 7 here. Super. Okay, now second case, let's say okay, this number is 5, this number is 4. So my larger number is on the left side. What will be my move? My move will be like this, because it is greater left side. Now right side is smaller, right side is smaller. Superb. Now left side greater, left side greater. I got it 7. Okay, from this path. So no matter, either this is maximum or maximum is on the left side. I can definitely move to the correct index. Super. I hope till that part everything is clear. Super. Now, there are two cases. Like first of all, first of all thing, why I am saying how dare I am saying this? Okay, my answer will be I plus one. So just to remind you, we are moving from right to left. Okay, we are moving from here. So my this answer is already ready. So that's why I am copying the same thing here. Now, why this is true? Let me tell you. Okay, so for example, just for example, when I'm trying to find the minimum number, okay, when I like for this example, prefix max is 5. When I was trying to find the suffix I plus 1, I got a 1 here, right? So in this case, suffix was lying just here. Was lying just here. So this is my current I, okay? This is my current I. Suffix can be at two places. Suffix can be at I plus 1, that means at this place, or it can be at I plus 2 or I plus 3 or I plus 4 or anywhere till n minus 1. Till n minus 1, there are two cases. Okay, either it will be at I plus 1 it will be I plus 2, I plus 3, I plus 4. Either it would be here. Okay, what is the minimum element? The suffix I plus 1. So I am just trying to find the index of this suffix minus I plus 1. So I hope till now the part is clear. So either like if this is maximum, we will be moving like this. Okay, and okay, let me redraw this one. Okay, super. So if this is maximum, let's say this is 6, so I can move like this and this. If maximum is present here, I will move like this, then this. So that way I will be able to reach the maximum answer. Now let's see. Now the second case is by like in this part we'll be carefully seeing what is happening behind the scenes. Superb. So this is 4, this is 5. Okay. Now what I will be doing is I need to find what I need to find. I need to find any number which is less than 4. Okay, if this condition is true, that means there will be at least one number present in this index. In this index, in this array, in the remaining part of right side, there will be at least one element which is smaller than this 4. Okay, so again, there are two possibilities. Either that minimum number, okay, there can be, if there are more than one minimum number, na, that is not a problem. But let's say there is only one minimum number and that is present in this part, okay. If that is present in this part, so what will be my possible answer? So this is all maximum. Okay, this is 17. Let's say this is 17, this is 12, and this is 16. All things are very large, and this is the only possible minimum number which I can get. So can I get any benefit from that answer? No, I can't. So whatever my answer present here now, whatever answer present at I plus 1, that will be my answer. Why? Because how I calculated answer for this, I think the prefix max. The prefix max was my answer for this, right? Because all numbers are greater and right side I need a smaller number, so I can't go right side. So whatever present at this, that is the only answer. Or if you can say if the rightmost element is the smallest number, then you can say that prefix max till now. That will be also fine. That will be also fine. There is no issue in that also. Okay. Super. First case is clear. Which case is clear? I think if rightmost is only a smaller number, only smaller. Okay. So only one smaller number is present in the right side, which is the right, just right. Okay. So this was 17, 12, and 16. So that's why this is the thing. Now let's say okay, there are more than one numbers which are smaller. In that case, what we'll be doing? Let's talk about the second case. Second case is basically okay, I am here. My current I is here. Okay. Now this number is not smaller. Okay. Like I got either it would be two smaller numbers in this area, or my smaller number is not present at I plus 1. Okay, this case is not there. In that case, what will be my answer? In that case, how I plus 1 is the only answer. Okay, let me tell you, let me prove that to you. Okay, so there will be again. So let's say my smaller number is here. Okay, this is my second smaller, this is first smaller, this is second smaller. So I got a smaller, this is smaller, there are two smallers. So I need to check what I will be proving. Let me tell you. Okay, I will be proving that there is a bridge between this number. Okay, if there is a bridge between this 4 and 2. Okay, there is a bridge between 4 and 2. There is a bridge between 1 and 2. 1 and 2. Okay, these are numbers. So can I say that there is a bridge between 4 and 1? I can say. And if there is a bridge, if there is a connection, if I can jump from 4 to 2, what does that mean? That means their answer would be same. If I can say there is a bridge between 1 and 2, that means their answer will be same. If this answer is same, okay, if bridge between 4 and 2 and this answer is same, is bridge between 1 and 2 and this answer is same, can I say that the 4 and 1 will be also bridge and their answer will be always same? Yes, let me prove that to you. Okay, I am here. Now, this is the prefix max. I am here. I am trying to find a smaller number on the right side. I found it. 2 is the smaller. Now, if 2 is smaller than this 4, can I say that it will be smaller than the prefix max? Yes, I can say. If from 4 it is smaller, from 5 also it will be smaller. From 5 it is smaller. So what will be my path? Okay. So my path will be like this: 4 to 5 and 5 to 2 and 2 to 7. Can I say that this I is connected to this is smaller? Yes, I can say. Let's say that smaller equal to j. Okay, smaller equal to j. Superb. Okay, so there is path between I to j. This is bridge. Okay, this is bridge. So there is a bridge between I to j. Now let me try to prove you that there is a bridge between I plus 1 and j as well. Why? Because let's say this is 4 or 5, whatever it is. Okay, if largest number can be here, it can be in the previous part as well. If this is this there can be two cases. It can be either maximum than this, it can be either greater than this 4, or it can be lesser than the 4. If in case if it's less, okay, in case it's less, can I try this path? Left side greater, right side smaller, left side greater, I can reach 7. Okay, this is first case. In case when this is smaller, let's say that it is 6, let's say it's 6. Let me how I will be moving, I will be moving like this: smaller, greater. That means whatever number present at the I plus 1 place, there is always bridge between I plus 1 and j. Okay, j is a smaller number on the right side. So can I say, if this is equal, this is equal, can I say that if both are equal then j, so I can definitely say that there is a path, there is a bridge between I and I plus 1. If this is the case, this condition would definitely will work. Let me again tell you. Okay, let's take again one more example. Understand properly what is happening. Okay, so here is my basically test case. Here are my indices, here prefix sum, suffix sum, and this is my answer. Okay, we will just focus on this part. Okay, let's say I am here, I am at 15. Okay, let me see okay, what is current maximum. Current maximum till now is 15, right? It's 15. Okay, super. Now, what is the suffix mean? I think suffix minimum from here till here, I think is 11. Super. Okay, this thing is perfect. Let me mark the correct index for you. I think correct index would be something like this. Okay, so that will be reusing everywhere to learn the thing. Super. Now, this is 15. Okay, I am at this index I. Super. This is I plus 1, and my j would be either my j would be here, which is the smaller, either my j would be lie in this range. Okay, so let me check. This is 15, this is 15. What, there are two cases: either my j would be here or my j would be in this part, mostly in this part. Okay, super. If my j is in this part, what will be the case? What will be the case? So I need to prove how these two are equal. How these two are equal? If this is my j, if this is my j, if this is I plus 1 is j, how this I and I plus 1 are equal? Because I can jump something like this, smaller, right? Left side is left side greater. So left side there is no greater, but I can directly go like this: 13 and 16, right? I can go like this. Super. Because this is the like prefix max. This is already a prefix max. That's why. Super. Now, if like is there path between this and this or not? So I'm at 12. I'm at 12. Okay. Can I go to Can I go to 15? Yes, I can go. Why I can go? Because left side greater, smaller, left side greater, right? Left side greater. I can go directly like this. That means there is a direct path. If there is a direct path, whatever answer is present here, that will be answer will be present here only. Also, okay. So whatever answer present here, that answer will be present here. Whatever reverse you can say. Super. So I can I plus one case is done. Now let's say my minimum is present in this part. So either it will be more than one minimum. There are more than one elements which are minimum in the right side of this 15, or there will be the minimum is not present here. The minimum is not I plus one, minimum is present in this I plus two to n minus one. It will be in this range. What will be my answer in that case? Let's see. I am here at 15. Now, this is prefix max already, so I don't need to move any left. There will be direct path. So, what will be my answer? I think I can go to here because I found a minimum. If I found the minimum, I can directly go. And if I found that minimum, I can directly go to this optimal index. First case. Second case is if this is not a minimum, if this is not a first minimum, this can be minimum or maximum. If this is minimum, can I go something like this? Yes, I can go. That means there is a breach. If that was, if let's say this was 17, for example, just for example, if this was 17, or let's take it, okay, 17 only. Okay, if let's say this is 17, can I move like this? Yes, I can move. Yes. Oh, 60, 17 is greater than 16. So let me take a 15.5. Okay, for example, just for example, 15.5. So if this is 15.5, I can't go like here because this is smaller and left side is smaller is not allowed. But I will definitely go like this 13 and 16. So that way I will be getting something like 16. Okay, I hope it is clear. Once we write the code, it will be more clear. So I think question is little tricky, but once you try run with yourself, you will be definitely able to solve this problem. And if you please, if you have any doubts, please feel free to ask in the comment section. Okay, so first of all, I will be calculating length of nums. Super. Now prefix, okay, let's write pref only. 0 into n. Suffix would be similar, 0 into n. Answer would be similar, 0 into n. Okay, now calculate prefix. And for I in range, I would be moving from 1. Okay, so prefix of 0 would be nothing but nums of 0. I would be moving from 1 to n minus 1. N means n minus 1. In Python, we write like this. So what I need to do? And also, C++, Java and JavaScript code will be uploaded soon. I will be not be uploading right now because there is some technical issue in my machine. So I'll be uploading in some time. So prefix of I would be max of prefix of I, comma, nums of I plus 1. I think it should be I minus 1. And this would be I. Okay, super. Now I will be calculate suffix. Calculate suffix, suffix of 0. Okay, suffix of minus 1. Minus 1 will be last index. Nums of minus 1. Super. For I in range from n minus 2. Why n minus 2? Because we are going from last second index. Last suffix, nums of last will be suffix of last, right? Super. Now suffix of I would be minimum of suffix of I plus 1 in this case, I think, and nums of I. Super. Okay. Now calculate main answer. Okay. For I in range. Well, from where I need to go? I think I need to go from n minus 2 to 0. Okay. So till 0 I am going. Okay, this minus 1 means I am going till 0. This minus 1 means I am jumping from minus 1, minus 1, minus 1. Okay. So first of all, my answer of I would be prefix of I. First of all, very first thing. And if prefix of I would be greater than suffix of I plus 1. If in any case, if this is true, that I can say that my answer would be answer of I plus 1. Code is really simple. But if you want to get why this code is working like this, uh, that is very important. Okay, I'm getting some wrong answer. Prefix of I, what I'm doing wrong. Okay, I forgot to do one thing. My answer of last number, answer of last will be always prefix of last. Why? Because for that last number, there is things in left, but there is nothing in right, right? So let's try to submit now. Okay, it is working fine. Let me try to submit it. It is working fine. Okay, so I hope guys I'm able to explain you this. If you still have doubt, please try to dry run it once yourself. Like when you dry run, you can dry run for this test case. You can dry run for this test case. If you dry run for multiple test cases, definitely it will be clear to you. And still, if you have doubt, please feel free to comment in comment section. We can definitely resolve it. And with that, thank you very much guys for watching this video. And if I am able to explain you this tough problem, just in case, please make sure you subscribe the channel so that that will definitely act as an OT motivation. That will be a simpler thing for you, but that will act as a very good motivation for me to create more such and such videos. So with that, thank you very much guys for watching this video, and we'll meet in the next one.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us.